Hello and welcome to our next video on problem solving with integer operations part 1. In this video, we're going to focus on whole number integers and some decimal integers. Let's get started. Number 1, different liquids freeze at different temperatures. This is called their freezing points. Liquid acetone, used in nail polish remover, has a freezing point of negative 137 degrees Fahrenheit. Water has a freezing point of 32 degrees Fahrenheit. How much warmer is the freezing point of water than the freezing point of acetone? So whenever they are asking you to find the difference between two numbers, it's most likely going to be subtraction. So you can see here is how much warmer is the freezing point of water than the freezing point of acetone. Is asking, well, what's the difference between these two numbers? So we are going to subtract. So we start with 32, and we're going to subtract negative 137. We learned about these double operations, so this is a minus a negative 137. And when that happens, I like to call it a plus positive. So now we just have two positive integers, 32 and 137, and we're going to add them up. That's as easy as adding 13 and 3, 16, and 7 and 2, 9. And that's going to be degrees Fahrenheit. So the difference between these freezing points is 169 degrees Fahrenheit. Let's try another one. In this question, it says, Carmen was scuba diving at 115 feet below the surface of the ocean. She swam up 20 feet to look at a colorful school of fish. What was her new depth? Sometimes with these problems, I like to draw a diagram. So in other words, this time here we have Carmen going a negative 115, and then she's coming back up 20. Well, that's a positive 20, right? As we're heading towards the positive. So we have negative 115. We just have to combine these numbers now. Negative 115 plus 20. So I have a negative and a positive, so I am going to subtract. And 115 is larger than 20, so I am going to have a negative answer. 115 minus 20 is as easy as 11 minus 2, which is 9. And then I have a 5 left over in my ones place. Negative 95 feet is the unit. Let's look at another one. It says here, Tex is the proud owner of Tex's Taco Truck. On Friday morning, Tex withdrew $100 for supplies from his account at the local bank. Then in the evening, he made a $250 deposit with money earned during lunchtime. What was the total change in Tex's bank account relative to where it started? There's a couple of things that I want to define for you. You might already know what they mean, but the first thing is withdrew. Withdrew means to take money out of your account. The next thing I would like to define for you is deposit. Deposit means that you're going to put money in. So let's start with the withdrawal. If Tex withdrew $100, that means my bank account is $100 lower. He then deposited $250, so that's positive. From here, we just have to combine these two numbers. So I have a positive 250 and a negative 100. That means I'm going to subtract. And 250 is larger than 100, so I know my answer is going to be positive. So actually, when we subtract 250 minus 100, it's simply 2 minus 1. Well, 2 minus 1 is 1, and I have 50 left over. This is money, so I'm going to put a dollar sign on it. But here's $150 in the positive. Let's take a look at another one. In this problem, Jared lost a total of $108 on his investment over 9 months. He lost an equal amount of money each month. Represent the situation above mathematically and solve. Whenever they ask you to break up something into equal parts, and in this case, it's months, right? We are looking at a division problem. So the amount of money we're breaking up is negative 108. And it's being broken up amongst 9 months. So a negative divided by a positive is going to be a negative. 9 into 10 goes 1 time. 10 minus 9 is 1 remainder. So we put the 1 with the 18. 18 divided by 9 is 2. Therefore, we can say that Jared lost $12 each month. In the next problem, after a winter storm, the depth of the snow on Cherry Street was 10 centimeters. But then it started to snow again at a rate of 0.8 centimeters per hour. What was the depth of the snow on Cherry Street after 3 hours? The line that stands out to me is 0.8 centimeters per an hour. So we got to think how that's represented, right? So if I have 0.8 after 1 hour, I would have another 0.8 after 2 hours, another 0.8 after 3 hours, and so on, right? We call this repeated addition. And whenever you have repeated addition, it's a fancy way of saying multiplication. So if there was 100 hours and we wanted to calculate, well, then we would just do 100 times 0.8. The other operation that's going on here is we're starting with 10 and we're adding the additional snow on. So they want to know, okay, well, what's my depth after 3 hours? So I'm going to start with my 10 and I'm going to add 0.8 times 3 hours. Well, to do 0.8 times 3, I just do 8 times 3. So I have 10 plus 24, right? And there is 1 decimal place here, right? There's no numbers after the decimal in 3, but there's 1 after in 0.8. So I'm going to move my decimal point 1 from the right, and I get 2.4. From here, we add 10 and 2.4. Well, we just add the numbers up to the left of the decimal point. So 10 plus 2 is going to be 12.4. And that is going to be centimeters of snow. There's one more question in this problem set, so let's take a look. It says here, Maggie's dad promised that he would double the amount of money she had in her piggy bank. If Maggie counted 18 quarters, 6 dimes, and 13 nickels in her piggy bank, how much money will she have once her dad pays what he promised? They go on to give you the values for each coin, quarter, dimes, and nickels, in case you didn't know them. There's a couple things going on here. The first thing is double, right? So we have to know that when we double something, we're multiplying by 2. So we're going to start with 2 times. From here, each coin has a value and a number. So she has 18 quarters, and quarters are worth 0.25. Again, each quarter increases the value by 0.25. So what we have is we have 0.25 plus 0.25 plus 0.25. It's repeated addition. Whenever we have repeated addition, and this whole concept of repeating is going to be a common thread in algebra. So it's important to kind of get a sense of what's repeating and what's not repeating. But anyways, we have 18 quarters, and we are multiplying that by 0.25. She also has 6 dimes. Multiplied by 0.10. And finally, she has 13 nickels, which is going to be multiplied by 0.05. Just going to fix this piece right here real quick. Well, the first thing we have to do is we have to figure out what each of these multiplication problems are. So the first multiplication problem that I see is 18 times 25. Again, when you multiply decimals, initially you can ignore the decimal points. So I have 1825. So here I have 8 times 5, which is 40. I have 16 plus 5 is 21. And 2 times 1 is 2. So now if I were to rewrite this problem over here, initially I have 0, 5, and 4. I can see that I have 2 decimal places in 0.25, so I move the decimal 2 positions from the right and I get $4.50. Here I see 6 times 10. Again, you ignore all of the decimal points. So 6 times 10 is 60. There's 2 decimal points in 0.10, leaving me with 60 cents. And then finally, I have 13 times 5, ignoring the decimal points. So 5 times 10 is 50. 5 times 3 is 15. 50 plus 15 is 65. And I have 2 decimal points in that problem. We have 3 decimals to add here. We have $4, so we'll start with $4. Keep that like that. And then I have 50 plus 60 plus 65. And again, anything over 2 decimal places is going to carry over to the next line, onto the 4. So 5 plus 6 is 11. 11 plus 6 is 17. So I have 1, 7, and then a 5. So from here, I can see that I had 2 decimal points, but I have 3. So the 1 has to carry over to the 4, which gives me 5. 75 total. But don't forget, we have to multiply by 2, right? That this 2 continuously has to come down, and now it's time to multiply by 2. So we have 2 times 5 is going to be 10. Carry the 1. 2 times 7 is 14 plus 1 is 15. Carry the 1. And 2 times 5 is 10 plus 1 is 11. We have 2 decimal points in 75. Therefore, I put my decimal point right here after the 11. That's money. Maggie is going to have $11.50 once her dad pays her double. That was the last question. If you have any questions for us, you could always ask your math teacher or send us an email. Thanks for watching.